In this question, there's a function from R to R. That means the domain being all real numbers and the range also is a real number. And the function is defined as fx is equal to ax plus b, where a and b belongs to real number, and a is not equal to 0 is bijective. That means we have to prove this function as 1, 1 and onto. Other way we can say that we have to prove that this function is injective as well as surjective. That's what bijective means. Now let's begin with 1, 1. For that, what we do, we take, let's say, let fx1 is equal to fx2 for x1 and x2 belongs to domain, that is real number. Now in this function, if I replace x with x1, we'll get fx1, which is ax1 plus b is equal to ax2 plus b. Now what we can see here that b and b get cancelled, so will be a and a. So we get x1 is equal to x2. Now, so once we get x1 is equal to x2, it verifies that this is 1, 1. Hence, f is a 1, 1 function. Now to check its surjectivity, that is onto, what we are going to do is we will take this function, say fx as y. So let fx is equal to y. So I can replace this fx with y. Then we can write y is equal to ax plus b. Now in the next step, I'm going to write x in terms of y. That means on transposing y, it's on transposing b, it's y minus b, that divided by a. Now you see y is what? A real number. And you need to keep in mind that a is not equal to 0. Now just check here, y being a real number, say y, I took it a real number, and real number minus b, which is again a real number, minus that divided by a. Once again, y being a real number, we have been given y being a real number, and that from which we subtract a real number, say b, and divide it by another real number, say a, except for 0, right? A is not equal to 0. We'll get a real number. That means we have y is a real number. So y minus b over a is also, or for a is not equal to 0, right? Or you may write, it's also a real number except for a is not equal to 0. So this is what? This is x. So y being a real number, we get x also a real number. Hence it is onto. Hence onto. So we can say this is 1, 1 on both 1, 1 and onto. So if you prove that the function is both injective and surjective, it's a bijective. So this is how this question can be done.